Hello students, so today in this video I will explain what are common hydrocarbon substituent groups which you often encounter in organic chemistry. So let's start. First I will explain what are these hydrocarbons. So as you know, hydrocarbon word is made up of two parts, hydro and carbon. So what is hydrocarbon? Hydrocarbon refers to those organic compounds. So basically these are compounds and specifically organic compounds containing only two kinds of elements, containing only hydrogen and carbon. So only these two types of elements will be present in hydrocarbons, and the compounds which contain only these two types of atoms or elements in them, these are called hydrocarbon organic compounds or hydrocarbons simply. So hydrocarbon compounds can be categorized in multiple categories. So let us see what are different categories which are falling under hydrocarbons. So first category is alkanes. Alkanes are also called saturated hydrocarbons. These are saturated hydrocarbons, and these are called saturated hydrocarbon because they are less reactive and less reactive because all the bonds present here are single bond. All bonds in alkanes, those are single bonds, and these are less reactive. These are also called saturated hydrocarbons. And one more thing is that the common general formula of this alkane family of compounds is CnH2n plus 2. So you can put different values of n here, different whole number values of n here, and you will get different members of this alkane family. If you put n equal to 1, you will get CH4. For n equal to 2, you will get C2H6. For n equal to 3, you will get C3H8, and so on. Okay, so these are the alkanes, and next category we will talk about, those are alkenes. And alkenes are unsaturated compounds because here one or more than one double bonds are present. Double bond is present. And the general formula for this family of compound is CnH2n. So one more thing I would like to tell you here, that this is true if only one double bond is present, right? If there are more than one double bonds, then this general formula will not be valid. So let us see, for n equal to 1, you won't get any alkene because for getting a double bond, you will need at least two carbon atoms where the one double bond can be formed, because carbon and hydrogen don't make a double bond. So at least two carbon atoms are needed for forming an alkene. So if you put n equal to 2, you will get C2H4. This is ethene, or you call it ethylene, common name. And next one you will get C3H6, C4H8, like this. So C2H4, if you want to write the structural formula for it, it will be C double bond C, and two atoms of hydrogen will be like this. Similarly, C3H6, C4H8, them also you can draw. These are alkenes. And next category is alkynes. Alkynes are also unsaturated class of compounds, and here there will be triple bond, one or more than one triple bonds can be there. And the general formula for this family of compounds is CnH2n minus 2. And again, I would like to remind you that this general formula is valid only if there is one and one only triple bond. So if there is only one triple bond, then this general formula for this family of compound will be valid. So if you put n equal to 1, you won't get any alkyne, because again, for forming a triple bond, you will need at least two carbon atoms. So if you put n equal to 2, you will get C2H2. For n equal to 3, you will get C3H4, right? 3 2 is 6 minus 2 4. For 4, C4H6, you will get 4 into 2, 8 minus 2 6, like this. And the first member here I have written C2H2. This is ethylene, or acetylene is a common name. This is propyne. This is butane. And if you want to draw the structural formula, the C2H2, that can be written as like this: C triple bond C, and one hydrogen here, one hydrogen here. Okay, so this is the structure. Similarly, you can draw the structural formula for the C3H4 and C4H6. So general formula CnH2n minus 2 is for alkynes, general formula CnH2n that is for alkenes, and general formula CnH2n plus 2 this is for alkane. And these two category of compounds, alkenes and alkynes, these are also known as unsaturated hydrocarbons. Because there is double or triple bond present, so these compounds are quite much reactive as compared to alkanes, and they give addition reactions easily, so these are quite more reactive as compared to alkanes. That's why these are called unsaturated hydrocarbons. And alkanes, due to having all the bonds single bond, and they don't usually give addition reaction, or even substitution reaction is not given by alkanes at low temperature or in low energy. So that's why these compounds are called saturated hydrocarbons, or sometimes they are also called paraffins. Paraffins means less reactive. Okay, so these three categories we saw, and there are few more categories. One more category is cycloalkanes. Cycloalkanes and alkynes can also be there, but we are not going to discuss them. Cycloalkanes are simple single bonded hydrocarbons which are closed chain compounds. So for example, you can draw like this. So here it is C, 3 carbon atoms, and other 2 free valencies will be bonded by 2 hydrogen atoms like this. So this is C3H6. So you can see that cycloalkanes, they also have the general formula CnH2n, which was for alkenes. Okay, similarly, and in short form, you can draw this structure just by a single triangle. So it is understood that the corners here, each corner represents 1 carbon atom, and other free valencies will be satisfied by hydrogen atom. Similarly, you can draw cyclobutane. Cyclobutane you can draw like this. Cyclopentane can be drawn like this. Cyclohexane will be drawn by this. So if you put alternate double bonds here, that will be your benzene ring, but you don't have to do that for cyclohexane. Cyclohexane is simple compound like this. So 6 carbon ring, and there is no double or triple bond. So all these are single bonds. Okay, so cycloalkanes. And one last category that I would like to discuss, that is your aromatic ring or benzene ring containing compounds. So aromatic hydrocarbons. What are aromatic hydrocarbons? So benzene ring, at least one benzene ring will be present here like this. So in benzene ring, there is, in this ring, all these carbons are occupying the corner position, and the free valencies will be satisfied by hydrogen atom, and alternate double bonds are also present here. 1 double bond here, 1 double bond here, 1 double bond here. So each carbon is having 1 free valency. Those free valencies will be satisfied by hydrogen atoms. Okay, and this can be represented by another equivalent structure where double bonds can change their position like this. So the actual structure, neither of these two structures, the actual structure is something in between these two structures, and these two are your resonating structures or canonical structures, and the actual structure of benzene is neither this or nor this. The actual structure is something in between these two structures, and none of the bonds in the ring is single or none of the bonds is double. Actually, each bond is equal in bond length and they are identical. So actual structure of benzene is drawn like this. We put a circle here, or sometimes in few books you can get that this circle is drawn with dotted line. This dotted line, this circle represents the moving or delocalized pi electrons present in these 3 double bonds. Okay, so let's come to the important topic. What are the important hydrocarbon substituent groups? So if you remove one hydrogen atom from these hydrocarbons, you get different hydrocarbon substituent groups. So let's discuss first alkyl group. So what is alkyl? When you remove one hydrogen atom from an alkane, you get alkyl group. So the general formula for alkane was CnH2n plus 2. If you remove one hydrogen, you will get CnH2n plus 1, and one valency of carbon will be free here. So this formula is for alkyl group. So let's see few examples. Like if first member we had CH4, which was methane, but if you remove one hydrogen from here, you will get CH3, and this is known as methyl group. So it is written as methyl, or sometimes it is also simply written as Me. Okay, and similarly second member of this family, that was ethane, C2H6, so corresponding alkyl group will be C2H5. This is ethyl group, or sometimes also written as Et. Similarly you can write propane, and corresponding member alkyl group, that will be C3H7. so this is your propyl group. Okay, so these are common alkyl groups. Similarly, if you remove one hydrogen from the alkene, then you get corresponding alkenyl group or alkenyl groups. Alkenyl groups. So like first member you had C2H4. So this was ethene, but if you remove one hydrogen from here, you will get C2H3, and this is called, basically the structure of ethene was CH2 double bond CH2, and if you remove one hydrogen, what you will get? You will get CH2 double bond CH, but one valency of this carbon is free, so that will be free. So this group, this is called ethenyl or ethinyl, or sometimes in common name it is known as vinyl group also. So it is important you should know what is vinyl. Vinyl is basically one hydrogen less in the alkene ethene or ethylene. Similarly, you can remove one hydrogen from propene also. So suppose the propene was CH2 double bond CH3. So this is your propene, and if you remove one hydrogen from this CH2 here, then one free valency will be CH2, not CH2, sorry, one hydrogen you have removed, so it will be CH double bond CH and CH3, and this free valency. So this group, this is propenyl or propenyl. This is one propenyl. So you could have removed the hydrogen from this position also, then what you will get? CH2 double bond CH and CH2. So this is 2-propenyl. Why 2-propenyl? Because you can see the position of double bond with respect to this free valency. It is at the first carbon, double bond is present, so it is 1-propenyl. With respect to this free valency, the double bond is present at 1 and 2, and the second carbon, that's why it is 2-propenyl. So these are the hydrocarbon substituent group, like vinyl group and propenyl group, or you can get butynyl group similarly in the same way. Okay, let's come to the third category, which is alkyne, and corresponding to alkyne you will get alkynyl or alkynyl, alkynyl group. So the first member of this alkyne family, that was acetylene or ethine, CH triple bond CH, and if you remove one hydrogen from this, you will get CH triple bond C and this free valency. This is your ethine. This compound was ethine, so it is ethinyl or ethinyl. Okay, similarly you can have second member CH triple bond C and then CH3. If you remove one hydrogen from here, so it will be CH triple bond C CH2. So this is your propynyl. So this is your 2-propenyl, and if you would have removed this hydrogen, then it would be 1-propenyl. Okay, so this is your alkynyl group, and last category we will see aromatic group. So this is important actually. Aromatic class of compound. So you have this benzene ring. This is called arene or benzene, and if you remove one hydrogen from, because every corner here represents one carbon atom and that is satisfied by one hydrogen, so if you free one hydrogen atom at one carbon, then this free valency is free. Now this group is called phenyl group or aryl group. Okay, and next member that is also very common and important to know. So if you put a CH2 here like this, so this group that is known as benzyl group. Okay, and there is one more compound, one more substituent similar to this, that is similar in name only. So this is your benzene ring, and suppose this is your one carbon atom and it is bonded by one oxygen with double bond and one valency is free. So this is your benzoyl group. And there is one more category, benzyl, that we will see. This here CH and two valencies will be free, not bonded by hydrogen. So this group is called benzyl group. Okay, and if all the three valencies of carbon is free, then what it will be? C, and all the valencies, three valencies are free. So this is known as benzo group. So these are very similar, you should remember. So this is benzyl, this is benzyl, this is benzo, and this is benzoyl. Okay, and this is your simplest one, that is the phenyl or aryl. And there is one more group that is commonly you should know, that is naphthalene. So if you know the structure of naphthalene, there are two adjacent benzene rings present like this. So this is naphthalene, and if you make one hydrogen go here, so make one, you make one valency free, so this becomes naphthyl, NaPH THYL. So it is coming from naphthalene, so it is called naphthyl group. Okay, so this was aromatic, and before moving last, I would like to tell you some functional group of substituent group, sorry, not functional group. So substituent group of this cycloalkyl class also. So there can be cycloalkyl substituents. So what can be cycloalkyl class of compounds? So this can be like, you have this cyclohexyl, and if you free one valency here, so this will be your cyclohexyl. Similarly, you can make cyclopropyl or cyclopropyl. Similarly, you can make one valency free in cyclobutyl, so it will be cyclobutyl or cyclobutyl. Okay, so that's all. That these are the common hydrocarbon substituent groups found in organic chemistry. When you will name these organic when you will learn about the IUPAC nomenclature of the organic compounds, you will need these hydrocarbon substituent groups to name. And sometimes in complicated situations, when multiple double bond or triple bond or double bond is, the compound is very long side chain is present, then you use IUPAC nomenclature for defining the position of double or triple bond in those type of substituents. So that's all I wanted to discuss with you people in this video. I hope you would like this video, and if you like it, consider liking this video and subscribing my channel also, and share these videos with your friends, and it will motivate me and it will support me. So okay, so that's all. Thank you very much. Take care and bye bye.